I'm Anil Kumar sharing with you a test question. Some of my students have trigonometry test tomorrow and I hope it is going to help them. The question here is Wine Grisky is 13 meters from the short side of the goal net and 14.7 meters from the long side of the goal. The dimensions of the NHL goal net are 1.86 meters by 1.2 meters. We have three parts to this question. Within what horizontal angle range can Gretzky shoot the puck in order to hit the net? Part B is, if Gretzky wants to hit the center of the crossbar, at what vertical angle must the puck be shot? C is, what is the diagonal distance from the puck's position to the center of the crossbar? So that's the question. You can always pause the video, answer the question, and then look into my suggestions. So let me make a diagram here which can help you solve the question. Let's say that's the goal line and the position of Wayne Gretzky is shown like this. Let's say we'll just take this point somewhere here, right? And from the other line position, kind of like this. Okay. So it's got extended a bit more than I wanted it to be. Anyway, so somewhere like this. Okay, let me push it a bit. Now the height of the goal is like this. What we are given here is these dimensions. From one side it is 13 meters, so this is 13 meters. From the other side it is 14.7 meters. This length of the goal is 1.86. So if I do the center, let me write 1.86 here, okay, and the height is 1.2, height is 1.2, all these dimensions are in meters. It is important to find the center distance also, so let me just connect this. Remember, in this situation these angles are not equal, okay. What are we trying to figure out here? We want to find this angle. Correct? So that is the position. So let us label these points. Let's say this is A for us, B, C, and let this be the center D, okay, for the time being. So part 1 is, within what horizontal angle range can Gretzky shoot the puck in order to hit the net? So that's the net, and horizontal angle really means the angle A, right? So from here we can apply the cosine law, right? Since we are given three sides, SSS, right? And find the angle. So what we know now is we want to find this angle A. So we can say BC square is equal to AB square plus AC square minus 2AB AC cos of A, and so cos of A is equal to, so I'm just rewriting the formula for those who don't really remember it. We'll bring it this side and we'll say AB square plus AC square minus BC square divided by 2AB AC, right? AB AC, and so A will be equals to, that is angle A is equals to cos inverse of all this. Let me put the values now. So AB square is 13 square plus 14.7 square minus this dimension is given to us as 1.86 square divided by 2 times 13 times 14.7. Is it okay? So that is what we need to find. So let us use the calculator to calculate this value. We do shift cos inverse it's good to put two brackets since we have numerator divided by denominator. 13 square plus 14.7 square minus 1.86 square, first bracket close, divided by another bracket for the denominator, 2 times 13 times 14.7, two brackets close, one for the denominator and the other one the whole, right? This big bracket equals to, so we get our answer as 3.128 degrees. So that is the angle which can be made at this position, right? So the angle is 3 point, let's say 1 degree. Is it okay? So that is part 1. Now part 2 is, if Grisky wants to hit the center of the crossbar, that means right there. If Grisky wants to hit the center of the crossbar, at what vertical angle must the puck be shot? So now we would like to find the vertical angle, kind of like this. Do you see that? So in this diagram, that becomes 90 degrees, and we are interested in this vertical angle. This is what we are interested in. So let's take up in the next page how to find the vertical angle. So I'll redraw and put the dimensions, and then we'll find the vertical angle. You can pause the video, find AD first. You have to find one of these sides, AD, and then we can do it, correct? So let's do it. So again, here is the question for you. I'll just sketch the scenario once again. This time I'll start from this point. Last time we went very far away. So this time I'm taking a precaution. I'm drawing a smaller diagram here. So that is the horizontal base, correct? Now we are looking into the vertical angles. So let me just make this relevant part. That is kind of what we have. Let me draw it in red, what we are interested in. So first we have to find this center and side length which joins this, and then we'll find joining this angle, let's say phi. So that is the angle we are interested in finding. We already know these distances, the horizontal distances, 13, 14.7, and we already calculated one of these angles, that is this angle. We calculated as, let me write this as 3.128 degrees. The whole length here is 1.86. Total is 1.86, so we'll do half of 1.86. 1.86 divided by 2 is, in decimals, 0.93. So this becomes 0.93. That is also 0.93, correct? Now in this situation, let us first find that angle, right? So let me label this as we did earlier. A, B, this is C for us, this is D, and let's call this point as E, okay. To find angle C, we can use cosine law. We know one of these angles and the opposite side, which is 1.86, right? Total length is 1.86, which is here, right? So the total is 1.86. Okay, so what we can do here is we can say sine C over the side opposite, which is 13, is equal to sine of the angle, which is 3.128. Let me take 3 digits as we found earlier, divide by 1.86, correct? So from here we can get what angle C is. So angle C is equals to sine inverse, I'm doing a couple of steps at the same time, will multiply by 13 all this, right? 13 times sine 3.128 divided by 1.86, correct? So let's figure this out. So now this time we have shift sine inverse 2 brackets as we did earlier. Let me delete one now. So we have 13 times sine 3.128 bracket close. That's for the numerator. Okay, and divided by 1.86, another bracket close. Okay, so that gives you the angle as 22.4, will approximate to 22.4, correct? Okay, so this angle is 22.4. Once we know this angle, we can find AD, right? We can find AD. Since in this dimension, AD, now we are considering the triangle. Let me redraw. We are considering now the triangle. Let's redraw. DCA, right? So we are considering the triangle. Let me just say like this. Okay. So, it's not to the scale. We are considering this triangle. Okay. So we have, okay. Let me highlight D. This is not a good diagram, so I'm just kind of leaving this. We are now considering this triangle, right? Now in this triangle, we know that angle is known to us, one of the angles. We have to find the opposite side. Perfect. We know these two sides. So we can again use cosine law to find AD. So what is AD equals to? AD is equal to, since it is opposite to this angle, so side AD will be A square plus B square, so which is 14.7 square plus 0.93 square minus 2 times 14.7 times 0.93 cos of 22.4. Let me write here cos 22.4, correct? So let's calculate this. This is square, so actually we'll do square root of all this. Since the space is less for me, I'm doing all this. Okay. So we'll do this out. So we have 14.7 square plus 0.93 square minus 2 times 14.7 times 0.93 times cos of 22.4 equals to, and we'll square root this, square root the answer equals to, so we get this as equal to 13.8447, correct? So this side we get 13.84, let us say. Now once you get this side, now in the triangle we have to find the angle, vertical angle, right? We are interested in vertical angle. So we can write down, now let me redraw the triangle, which is the vertical triangle. So we have this side here, and I'm trying to draw the vertical angle separately. We have this triangle now. So we are talking about this triangle now. Is that okay? And angle phi. We have already calculated the horizontal side as 13.84. We know the height of this is 1.2 meters, and we have to find the angle. So that becomes tan theta, right? So tan theta, or in this angle I've written as phi, is opposite 1.2 divided by 13.84. So phi is equals to tan inverse of 1.2 over 13.84, correct? So let's figure out this one. So we have shift tan inverse 1.2 divided by 13.84, which is equal to 4.955. So I can round this to 5 degrees, right? So this could be rounded to 5 degrees. So this is equals to 5 degrees. So I hope with this all the calculations are understood, and with calculator it makes it easy to do these calculations, and I hope it helps you in your test, correct? Now, based on this, I have a question from my subscriber which says very similar question. Sidney Crosby is 6.2 feet from one goal post and 4.5 feet from another. The dimensions of the hockey net are 3 feet by 6 feet, correct? What should be the maximum angle? So you can do this as a practice test question for you. So let's say we'll again make this diagram. Okay. So what we have basically, I'm only drawing the base, which in this case gives you 6.2 feet as one side, 4.5 feet for the other. The dimensions are 6 feet by 3 feet. So let's say that is 3 feet. Is it okay? Okay. We are interested in finding this angle, theta. So you can use cosine theta when three sides are given, SSS, use cosine law to find this angle. So you can say the angle or cos theta will be equal to these two sides square, 4 point square plus 6.2 square minus 2 times 4.5 times 6.2 times this square plus this square minus 6 square, because we are trying to find angle, right? Minus 6 square divided by 2 times 4.5 times 6.2, correct? So that becomes the cosine, and theta of course will be equal to, let me rewrite since I messed it up. So theta will be equals to cos inverse of, within brackets, 4.5 square plus 6.2 square minus 6 square divided by 2 times 4.5 times 6.2. Right, let's calculate. It is shift cos inverse, so second bracket, for 4.5 square plus 6.2 square minus 6 square, so the numerator bracket close, divided by, the denominator is 2 times 4.5 times 6.2, bracket close for denominator, another bracket close, and that gives you the answer as 66 degrees, correct? So in this particular case, the answer is 66 degrees is maximum angle. I hope that helps, right? Feel free to post your suggestions and comments, and thanks for posting this question. Thank you and all the best.